authored 18 international research publications and filed 22 patents. He is graduated from IIT Delhi.
Okay, holding on to this last talk of the day. I think all of you are jaded, and I don't have much time. So I'm equally as rushed as Gandhari. So try to wrap it up in 5 minutes. So in 5 minutes, what can I do? I would have done my job if I would have cleared the air about data science and what do data scientists do, right? We've heard this term over the last couple of days, I'm sure, and you would have been hearing this term in the news. Mukherjee has quoted that data scientist is the sexiest job of the 20th century, and she said that your CEO wants data science to build a data science team. So what do you get with a data science team? It'll be good if we look at a few examples of what data science how data science is put to work in a consumer internet startup. And I'll use some examples from my company, but you can take these as representative of any consumer internet company. Right. So a little bit about Hike, just one slide. I'm not sure how many of you are aware of Hike Messenger. So we are famous as one of India's top messaging apps with a focus on richer messaging through localized stickers and better privacy through features like hidden mods, etc. We also believe that we can become messaging as a platform for delivering content and services. If you look at the mobile app ecosystem today, one of the things that is broken is content discovery. For each bit of content, you need yet another app, right? So why cannot all of that come in a single app, which gives you all the content and services that you need? That's where Hike is moving towards, and you can expect a lot of that to come in the next few years. We already have stuff like news on Hike, games, native games on Hike, and other content like cricket scores, etc. So you have messaging on one hand, you have content and services on the other hand. Let's see what data science can do. Just a couple of data points just to give you an idea about scale. I'm sure speakers would have talked about how data analytics becomes more powerful, or big data becomes more powerful with scale, right? So you throw more data at the problem, the better the insights will be. So we've crossed 100 million registered users this January. That makes up the top used mobile app that is born out of the country. Every month we process over 40 billion messages, right, in over 20 languages. So this sets us with good data to do some data science on, right? So what's the mission of a data science team? So the mission of the data science, as I see it, is to unlock the true potential of the data and to put it to use to create sticky experiences and products, and also power systems and analysis that scale business growth. So I talked about products. So you have products on one hand, which is the end user facing value. So how can data science create stickier experiences in the product? And on the other hand, it's the more internal facing. So how can you make your business functions more equipped and more intelligent to take the right business decisions, right? So, and all of this is triggered and is built on top of what you have at the bottom, which is the data infrastructure, where all the big data is piling in. So you need to develop adequate systems that can support that kind of a scale, right? Create different scalable data stores to support different kinds of querying needs of different applications. And then on top of that, you have knowledge and insights, which is where the core of data science is. And I'll sort of further elaborate with some examples specifically from how this kind of a stack looks at Hike. So at the very bottom, these are some of the data sources that we see. So we have event analytics coming from all the user activity that we are seeing on our app. Just to give you an idea of scale, we process over terabytes of data in a compressed format every day. That is the scale of the data that passes through our system. We have this social graph. I'll talk a little bit around this. And then we have the content feeds, as I talked about, news and other kinds of content. All of that is coming in, both the content as well as metadata around that, right? On top of this, what can you derive which helps you a deeper understanding of what this data is? And that is where the knowledge and insights layer sits. So a couple of examples here. Knowledge and insights around users and networks, right? Can you have a deeper understanding of who the user is, what is his personal preferences, what is his identity, and what is his context at that point in time, and then about his network. So how strong are his social relationships with other individuals on his contact book, right? On the other hand, if you look at content, there are lots of things. So whenever it's about relevant content delivery, we have recommender systems, and a lot of work at Hike happens around relevance and ranking. You also have, because we are a mobile app, and we have lots of cool applications around photos and filters, a lot of focus around computer vision, and that's a key area. Conversational modeling, again, we are a messaging app. We also have a bot on top of our platform. So to create bot experiences, you need to model conversations through artificial intelligence, right? Sneak peek at some sample set of applications in products that this is driving. This is enabling content personalization, friend recommendations, sticker suggestions, filters, lenses, bot experiences on the product side. I'll touch upon some of these in a little more detail without taking much time. And on the growth and marketing side, which is the more internal facing thing, how do you forecast growth better? How do you prevent customer churn? How do you model, how do you acquire the right set of people? If you want to invite the right set of users, who will those users be? And so on, right? Hike social graph, just to give you an idea of the scale. So I think Anand was talking about social graph quite a bit. So Hike social graph is look at the scale, hundreds of millions of nodes and tens of billions of edges. How do you process such large graphs at scale and derive some value out of it? So this is a trivia thing. So we all know that Hike is a social platform, right? Anand was coming up with examples from Mahabharata. So a lot can be done even without knowing semantics of the data. Right from the data itself, you can predict things about what data it is. So here is a classic example. So when you look at a social graph, there are properties that distinguish a social graph from any other graph. And this is one such thing. A social graph, if you look at on the right hand side, you have a social graph, which is also called a scale-free network. And on the left-hand side, you have a random network, right? So you'll notice fundamental differences about these networks. So what are some of the differences? One is that you'll see in a social graph, it gets clustered around some pockets of the network, right? The other thing that you'll see is this thing around degree distribution. So in a random network, the degree distribution, which is what is the fraction of the nodes with a certain degree, that follows kind of a Gaussian distribution, a binomial distribution. In case of a social network, it follows a power law. And we just have some proof. If you analyze Hike network, it will follow some of those things. So to a computer scientist, even without knowing anything about Hike, just given the graph, he can vet that this is a social network. Right. So coming to some of the use cases, I talked about friend recommendation as one use case. So here's the problem. So how how do you recommend someone in the network who you are more likely to engage with? So that's friend recommendation. The flip side of the coin is, how do you invite a new user onto Hike who's more likely to stay on and engage on top of Hike, right? So how do you predict, how do you trigger how do you drive some of these use cases? The classic problem is that of link prediction. Given any two nodes in that network, how can you predict the level of affinity between the two nodes, right? And then there are different algorithms, and for the paucity of time, I'll go just over the use cases and not too much into the algorithms. I talked about creating sticky experiences, and stickers, in fact, is one of our most flagship features. So these are the kinds of recommendations or suggestions that you would use when you use Hike and you use stickers in Hike. It will help you use stickers through a variety of recommendations, and these are some of the varieties. So on the left hand side you have stickers as you type. So based on the text that you start typing, you will have stickers come up. In the middle you have, if you tap on a sticker, given the context of the sticker, I can suggest you more stickers which are suitable replies to the sticker, and all of this is learned from data. So if you have a sticker shop, how can you enable personalized content, and so how can you enable the sticker shop to be personalized differently to different users based on his taste, based on his language, etc. All of that is being driven through personalization and data science. I'll skip over some of this, jump into yet another use case. When it comes to content applications, there are two sides of the coin. One is that how do you manage content, right? You need to tag content appropriately. You need to manage a taxonomy. So those are problems on the content management side. So you have thousands of articles that are streaming in every minute. Many of them are duplicate or many of them are related. How can you automatically figure out which articles are related, right? Again, a classic data science problem. You have, so on Hike, against every news article, we give a 60-word summary of the news article. Even that can be automatically generated, right? So automatic content summarization is yet another problem. When it comes to delivery, you need to enable the right content to reach the right users, right? So content personalization, but even before we go to personalization, you have tens and thousands of news articles that are streaming in every minute. Only a handful of them make it to a breaking news status. How can you automatically predict that which article has potential to become a breaking news, right? How can you learn that from data, and how can you learn that at scale? And that is where some of these algorithms come in. We take inspiration from algorithms which bandits have been using in casinos. When you are going into a casino, you have a line of an array of slot machines. Which slot machine will give you most reward, right? And how do you systematically find it? By exploiting the machine which is giving you most reward, you play it a little bit more, and then after a certain point you will stop getting reward. So you will switch to another machine, and in the hope that it will give you some reward. So similar inspirations, so this inspiration has led to a family of algorithms that we know by the name of multi-armed bandit algorithms, which help us solve problems of identification of what is trending, what is popular, what needs to be promoted, for which news article do I send a notification and to whom, right? All of these are classic data science problems. I need to end because I just had 5 minutes and I'm already over time. I'll end this with this last one slide. It's also related to what Gandhari was talking about. It's a culture of experimentation. As a data science team in an organization, especially in a consumer internet company, you also want to promote the culture of experimentation. In a company such as ours, every day, every employee will come up with tens of ideas, right? And all of these ideas have some merit. So what you want to do is you want to experiment very, very quickly with thousands of ideas, right? But only a very handful of them will actually be successful. So how do you quickly identify that idea which has potential and promote it and launch it and scale it and fail fast with the rest of them? This is possible through A/B experimentation and putting adequate tooling and method and processes around experimentation. A few things which are very important here: framing the right hypothesis, right, and defining the right success metric, which will help you measure, defining the right sample size. So depending on what is the success metric and by what amount or what degree do I want to move it, I would need an statistically significant sample size to launch the experiment with, right? So you define the sample size, you design the experiments carefully, and then you need some tooling to run multiple experiments at the same go without each experiment hitting onto and polluting another experiment, right? Because there may be 5 experiments or maybe 20 experiments that are running at the same time, and if a single user is being exposed to all of those 20 experiments, you would not know what experiment is having what impact. So it's very important to have methods and processes and tooling to have careful experimentation. And finally, you productionize the certified variants which succeed and in this loop of experimentation. So I'll end at that. Any quick questions? I'm around, so we're absolutely out of time. So thank you.
Thank you so much, Mr. Mukherjee. Requested to be on the stage. I would request Mr. Uttam Mane to felicitate Mr. Debdoot Mukherjee and Mr. Narendra Sahu.